The topic to be discussed in this video is basic nodal capabilities. In this concept, a remote device generally needs to have a basic protocol stack that supports as a minimum local connectivity and networking connectivity. For network connectivity and the local connectivity, every device in the sensing region requires some basic protocol stack. That is very, very important. A remote device generally needs to have a basic protocol stack. A basic protocol stack that supports as a minimum local connectivity and networking connectivity. Okay, next protocol stack, basic protocol stack here. Basic protocol stack. With the help of that basic protocol stack, each and every remote device in the device area, M2M device area, connected to the minimum local network, M2M area network, and networking connectivity. Here, the important basic protocol stack, each and every layer consists of some protocols. This one is a application layer. HTTP, hypertext, that is very, very important. Hypertext transfer protocol, FTP, file transfer protocol, simple mail transfer protocol. These are some important protocols. Coming to transport layer protocols, we use TCP and UDP, transport layer protocol. And coming to network layer protocol, Internet Protocol version 4 and IPv Internet Protocol version 6. These are the two protocols which are used to connect the devices to Internet. That means IP protocol, Internet Protocol. Next one, coming to data link layer. Wi-Fi, WiMAX, worldwide interoperability microwave access. For mobile communications, we use GSM. GSM is nothing but very important. Global System Mobile Communication. GSM is the Global System Mobile Communication. These are the some important protocols. Global System for Mobile Communication is an open and digital cellular technology used for transmitting mobile voice and data service. One more important here is DSL, digital subscriber line, HFC, hybrid fiber coaxial cables, satellite. There are some technologies. Digital subscriber line DSL, Global System Mobile Communication GSM, UMTS. Another one is the Universal Mobile Telecommunication System. UMTS, Universal Mobile Telecommunication System. All are belongs to these are the application layer protocols. Application layer protocols. These are the transport layer protocols. Transport layer protocols. These are the network layer protocols. Next one, data link layer protocols. Coming to this one, here some M2M devices, M2M device area, M2M area network, M2M area network, and gateway node. These are the two types of connectivities are there. Here local connectivity. Here local connectivity. M2M area network is used to connect these devices, M2M machine to machine devices. These devices are sensors, smart watches, smart refrigerator, smart TV, smart mobile, smart AC, and so on. This is the local connectivity. This one is the in case of data by using a data link layer, connect these devices globally. That is called as networking connectivity. Networking connectivity. Okay, these are the. This is the previous one. Current internet protocols. These are the current internet protocols. Coming to expected IoT protocols. Expected IoT protocols. Here we use in the application layer MQTT, message queue telemetry transport protocol, COAP. COAP means constrained application protocol. COAP is the constrained application protocol. AMQP. Advanced message queuing protocols. Advanced message queuing protocol. These are the expected IoT protocols at the application layer. Coming to transport layer. In the transport layer, two types of protocols are used here: user datagram protocol and transmission control protocol. In case of networking layer, IP protocol, internet protocol, IPv version 4 and IPv version 6. These are the two protocols are used in networking. In case of data link layer, Ethernet, Wi-Fi, GSM, long-term evaluation, LTE, 3G, 4G, Sigfox. These are the for global connectivity. That means networking connectivity. We use these technologies: the Ethernet, Wi-Fi, GSM, LTE, Sigfox, WiMAX, and so on. Coming to this one, expected protocol region, again local connectivity. That means gateway node, M2M area network, M2M device. This is for local connectivity. Every device in the M2M area requires some protocol stack. These are the protocol stacks. Some protocol stacks for connecting for connectivity, that is called as local connectivity and networking connectivity. For connectivity of these devices, we need some the connectivity of the devices to the local connectivity and the network connectivity requires some protocol stack. That is called as a remote device generally needs to have a basic protocol stack. See the basic protocol stack that supports the minimum local connectivity and network connectivity. Now I will concentrate on local connectivity. What is meant by local connectivity? M2M area network. Here the main one, M2M area network. It provides the connectivity between this M2M device and M2M gateway node. It provides connectivity between M2M devices and M2M gateway. Examples of M2M for local connectivity: M2M area networks. M2M area network. We know that PAN, Personal Area Network, ZigBee, Low Power Wireless Personal Area Network, Bluetooth, IETF, Internet Engineering Traffic Force, defines new standards of Internet. Other local networks such as power line communication, PLC, PCL, power line, PLC, power line communication, KNX, M-bus. So many technologies are used to connect the devices. That is called as in M2M area network. Okay, the local connectivity means the heart of that local connectivity is the M2M area network. It provides a connectivity between M2M devices and M2M gateways. Coming to this one, second one, data link layer. Here's some data link layer. Network connectivity. Here's some network connectivity. Networking connectivity. What is meant by all of you must know the network connectivity. Generally, network domain sometimes. A network that allows the M2M device and gateway domain to communicate the core network via the access network. First one, access network. Access network. Here, this is a M2M device and M2M gateway node. That entire one is called as M2M device and gateway domain. M2M device and gateway domain. In this case, a local connectivity is possible in this region. The heart of that this region is local connectivity region is M2M area network. Some technologies are used to connect these M2M devices based on the application. Sometimes we use Bluetooth, ZigBee, and KNX, personal area network, and so on. Suppose here, these a network that allows the M2M device and the gateway domain to communicate with the core network. That is called core network. Here, access network, a network that allows the M2M device and gateway domain. M2M device and gateway domain provide some local connectivity. The gateway domain to communicate with the core network. Core network means BSNL central office, Geo central office, Vodafone, Vada, all are internet providers. Geo central office, BSNL central office, and Airtel. Not Vada. Here some Airtel, etc. Some access networks. A network that allows M2M device and gateway domain to connect with the core network. core networks are BSNL central office, Geo central office, Airtel, etc. Some important access networks are some examples of access networks. Digital subscriber line, HFC, hybrid fiber coaxial cable, satellite, GSM by edge radio. These are the technologies. Edge radio, Wi-Fi, general GPRS, general packet radio service for mobile communications, GSM, edge radio, GPRS for mobile communication, UMTS, universal mobile telecommunication system. GSM means global system for mobile communication, and HFC means hybrid fiber coaxial cable, satellite, GSM. These are the some important access networks. And also WiMAX. WiMAX is worldwide interoperability for microwave access, 3G and LTE for mobile communication, FTTH. FTTH means fiber to the home. These are the technologies. These are the very important technologies which are used to connect the devices, M2M devices. That means M2M and M2M gateway domain to core network. Core network means BSNL central office, Airtel central office, and Geo central office, etc. These are the core networks. Some active access networks are play an important role here. These are the access networks. Each and every device in the device area, M2M area requires some protocol stack for the connectivity. Two types of connectivities are there: local connectivity and networking connectivity. In that case, protocol stack play an important role. This is the protocol stack, current internet protocol stack, and expected internet IoT protocols. Some few protocols are modified here, used here: MQTT, COAP, and AMQP. Next important point here is IoT device may have capability differences. IoT devices may have. Here, second point. First, we need some protocol stack for connectivity, local connectivity and global connectivity, networking connectivity. Next, second point, important point is IoT devices may have capabilities such as MTU. MTU means MTU, maximum transmission unit. Maximum transmission unit. IoT devices have different. IoT device may have capability differences. First one, some device produces more data, some devices produces less data, and so on. Some intelligent device incorporated with extraordinary features. Some of the devices are not incorporated with extraordinary features, and so on. MTU is the maximum transmission unit. The data in the form of bytes. Some devices produces more data, some devices produces less data. That thing is related to MTU, maximum transmission unit. Second one is simplified versus full-blown web protocol stack. Web protocol stack. Here constrained COAP, constrained application protocol versus UDP. Constrained application protocol uses UDP services, and HTTP, hyper text transmission protocol, uses TCP. Here, this one is a simplified. This one is a hypertext. This one is the current internet protocols. We use HTTP for accessing the web pages. We use HTTP and FTP, SMTP. In case of devices are millions of devices are connected worldwide. We need some protocols, some application protocols. MQTT, COAP, AMQP. That is the simplified. This is the simplified versus full-blown web protocol stack. This is the another difference. This is the another difference. First difference is data generation. Some devices generates more data, some devices generates less data. That is related MTU, maximum transmission unit. Some in the second difference is simplified versus full-blown web protocol stack. In case of ordinary protocol stack, we need HTTP. In full-blown web protocol stack, we use COAP, UDP, and HTTP, TCP. Single stack versus single stack versus dual stack. Some devices need IP Internet Protocol version 4 for connectivity the devices to network layer. That is called as a single stack. Some devices need both IPv4 and IPv6. IP Internet Protocol version 4 and Internet Protocol version 6. Both are needed to connect the devices to the network layers. That is very, very important. Here, in case of Ethernet, here some in the data link layer. For local connectivity, Ethernet is used to connect the devices. In the network layer, we use Internet Protocol version 4. In transport layer, TCP and UDP. And finally, You'll get Internet Protocol version 4 application. In some cases, this is the single stack. In case of double stack, IPv4, both versions IPv6. IPv4 and IPv6 both are used here, and TCP, UDP, TCP connected IPv4, TCP connected IPv6, UDP connected IPv4, UDP connected IPv6, and these are applied to application layer. Both are IPv4 and IPv6, IPv4 slash IPv6 applications. This is called as a dual stack. This is the difference, simplified versus full blown. Next one is single stack versus dual stack. Next one, sleep schedule. Schedule. Suppose that node or device involved in the communication, it loses some energy. That means the node lifetime gradually decreases. Once the node lifetime decreases, once there is no energy available for the involving the communication, processing the data, at that instant, the node is in dead condition. That node is not involved. Remove that node. Really, millions of nodes are there in IoT. In that case, we will follow the sleep schedule. That is the one of the difference. Sleep schedule means most of the, suppose the node is not involved in any communication or any computation. Computation means process the data, execute the data. At that instant, the node is put in sleep condition. Otherwise, the node is in on condition, it loses some energy. Finally, there is no energy available for processing the actions. Therefore, the node is in dead mode. Sleep schedule is very, very important. Idle mode, active mode, rest mode are the important modes which are used in sleep schedules. Next, security protocols. These devices are the device in the IoT systems are open access to all the persons. That is the reason we need some security protocols, secure their information. Device to device, that security concept changes. That is the difference, another difference. Next one, processing and the communication bandwidth. Some device having more processing capabilities, some device having less processing capabilities, and also some communication bandwidth. These are the some differences. IoT devices may have capability differences. Single stack versus double stack, dual stack. In single stack case, the devices uses IPv4 version. In double stack case, the device uses both versions IPv4 and IPv6. In case of maximum transfer unit, some devices are produce more data, some devices are produce less data. That is also related to capability. More data means maximum transmission unit. Protocol stacks are also used for very important. Protocol stack is used to connect the devices locally and globally. Some protocols are used simplify in the original protocol stack. In IoT applications, we add some more protocols. That is called a simplified versus a blown web protocol stack. Coming to sleep schedules. Suppose the node is nothing but a device or thing, whatever it may be, involved in the communication. It loses some energy. Finally, the energy is not available to process the data, and the device that energy is not enough to involve that device in communication. At that instant, the device is in dead condition. Therefore, we should follow the sleep schedule: normal mode, active mode, and rest mode. Security protocols. The devices are open in IoT applications. Anybody will access the device's information. Suppose some important information is there, at that instant we have to protect that information by using security protocols. Final one is processing and communication bandwidth. This one. Protocol stack. Already explained all these concepts. This protocol stack play an important role here. Here, device hardware. Communication is from bottom to top. Data ending here, data is generated. That means data ending point. Here, data DEP means data ending point. Here, data integration point. Here some applications are there. Meters. Smart meters means water meter, smart water meter, smart gas meter, smart energy meter. Okay, how to connect all these meters? By using power line communication. What is meant by power line communication? The power line communication uses existing electrical lines. Power line communication is nothing but internet over existing power lines or electrical lines. These devices are connected. These devices are low power devices are connected by using M bus. Okay, that is called as a device hardware. In case of wireless body area network, what are the devices are used here? Sensors, biosensors, and motion sensors. Biosensors are used to monitoring the blood pressure, heart rate, glucose level in the blood, and pulse rate. These are the parameters are monitored by using biosensors. Coming to motion sensors are used to indicate the current position of the patient, standing, sitting, falling, running, walking, and so on. These are the sense. How these sensors are connected? That is by using Zigbee. By using Zigbee is a low power personal area network. All these devices are sensed and they generate some data. That data is sent to gateway node. The data is sent to gateway node. The gateway node is connected to internet via some access networks. Some direct connectivity is there. Some via access network is also there. Connect these devices to internet. Coming to these are the some IP smart objects. So many applications are there. This is the M2M device region. Device region or area. Here machine to machine, all are machines. Here smart meter, smart gas meter, smart energy meter, all are machines. These machines are connected by using some M-bus with the help of PLC, power line communication, existing electricity lines with electrical lines with internet. That is called as local connectivity. That is called as local connectivity. Here some biosensors are also nothing but devices. Motion sensor are also nothing but devices. Zigbee is the local M2M area network. Here PLC and M-bus is the M2M area network. Here Zigbee is the M2M area network. That is the local connectivity. Next, coming to network connectivity. What is meant by network connectivity? Consider any application. Here consider body area network. In that device hardware, M2M devices are sensors, biosensors, motion sensors. These sensors are placed on the body of the patient, monitor the conditions of the patient, generates some data. How these sensors are connected? These sensors are connected by using Zigbee, low power, low data rate wireless personal area network is used to connect these sensors. That is called as a local connectivity. Coming to network connectivity, here we use two types of protocols are used, versions are used. IP protocol, IPv version 4 and IPv version 6 protocols. Based on that application, we use for IPv6 more address space is available. Header length is very less compared to IPv4. IPv6 is the 120 bit data, 120 bit. 2 power 128 address spaces are available. That is called as for network connectivity. Here some application support protocols. Very important. Application support protocols. Here combination of application layer protocols, application layer protocol, and transport layer protocols. Transport layer protocol. In this case, we use in this case constraint COAP. Here in transport layer, we use two types of protocols: UDP, user datagram protocols, and TCP. transmission control protocols. COAP, constrained application protocols, and another one is hypertext HTTP, hypertext transfer protocol. By combination of these two play an important role. Example, so many application layer protocols are used. Layer protocols are there in IoT applications. TCP, HTTP, and COAP and UDP. Okay, first one, COAP. COAP is nothing but a constrained application protocol. COAP is the constrained application protocol. COAP is an internet utility protocol for constrained gadgets. Constrained means a low power, low bandwidth, low power, low memory capacity, low power, low memory capacity. Execution capacity is very less. That means these are the constrained nodes. COAP is an internet utility protocol for constrained devices. For constrained devices. This protocol is designed to enable simple constrained devices to join IoT through constrained networks having low bandwidth and low availability. This protocol is a design, that means it is designed to enable simple constrained devices to join IoT through constrained networks. Having constrained networks means having low bandwidth and less availability. This protocol is probably designed for IoT applications. This protocol is primarily used for machine-to-machine communication. This protocol is primarily used for machine-to-machine communication. Machine-to-machine communication. M2M, and is particularly designed for IoT systems. This is the application layer protocol. COAP, constrained application protocol, uses of the UDP protocol for lightweight implementation. What is meant by lightweight implementation? A lightweight protocol in computer network is a communication protocol that is characterized by relatively small overhead. The length of the message unit and overhead header of that unit is frame is very less. That is called as lightweight. It also uses resetful architecture. Resetful architecture. Resetful means reset. Reset stands for representational state transfer. Very, very important point. Representational state transfer and API, application interface, application program, stands for application program interface. RE reset representative state transfer is a software architectural style that defines the set of rules to be used for creating web services. Creating web services. REST is a software architectural style that defines the set of rules to be used for creating web services. Next important one is Hypertext Transfer Protocol, HTTP. Hypertext Transfer Protocol, that is also a very, very important protocol. This protocol uses to access the web pages. This protocol uses the access of the web pages. I am the client. Server is the I am the client. Server here. Server is service provider. Suppose I want to open the web pages by using some HTTP says www. That is World Wide Web. Some google.com. That is the request to the server. Server immediately responds to the client. Open that Google browser. Google. By using that Google, have to search the required documents. In this case, HTTP play an important role. HTTP protocol, resources are exchanged between client device and the server over the internet. Resources are exchanged between client device and servers over the internet. That is very, very important. Here, there is some application support protocols, COAP, Constraint Application Protocol, and HTTP, hypertext transfer protocol. Hypertext transfer protocols are used to search the web pages on the internet. Constrained application layer protocols are used to connect the constrained nodes to the IoT network with the help of constrained networks. Constrained network means low availability and low bandwidth. COAP also uses HTTP for accessing the web pages. In this case, COAP application layer protocol uses UDP applications. HTTP hypertext transfer protocol uses TCP transmission control protocol applications. Last one, middle layer. Middle layer is play an important role in IoT. That is the new layer. Middle layer acts as an agent between the service providers, that means IoT devices, and the service consumers. And the service consumers means here different types of servers are used here. Medical server, that is the data is stored in the cloud. Weather server, traffic examine server. In this example, we use body area network. That means the middleware A of device A. That means body area network. That middleware acts as an agent between the service provider. Service means these sensors are used to create some data, some services. Service providers, between the service providers, IoT device, and service consumers. Service consumers means medical servers. Doctor examine the patient condition. How doctor examine the patient condition in IoT applications? Once the doctor receives the information from the patient through this from bottom to top approach, examine the medical server, examine the previous history and present history, compare these two, and then suggest the instructions to the patient. Any doctor has interested to gather the information from the medical server. That is the M2M application. Middleware acts as an agent between service providers, devices, and service consumers. It is a software layer, fits in between application and objects. In between, this is the application layer and this one is the object layer. Middleware is the in whole universe. Different types of devices are there. Different types of devices are generates trillions of data. Some interoperability is missing in middleware layer provides interoperability among all these devices in the worldwide. In the middleware, process the data, store the data. So many applications are attached to middleware layer. It is a mediator interface that enables the interaction between the internet and the things. Middleware provides solutions to frequently encountered problems such as interoperability, security, and dependability. Finally, the data is getting from the middleware. Here different devices are there. Different devices are different operating conditions, different characteristics. We have to make heterogeneous characteristics. You have to maintain interoperability among these devices that can be possible at the middleware layer only. This is the cloud layer, important layer in IoT. Graphical user interface. This is the ones from this bottom to top devices to middleware. the data is generated. That is called as data ending point. The data is stored in the particular server. Some in case of energy management, that means meters, energy meter. Here at the device hardware, we use energy meters. That means water meter, energy, smart water meter, smart energy meter, smart gas meter. All these are connected by using power, power line communication, PLC, by using on the M-bus. Here the data is generated at the middleware. That middleware data is stored in the energy management server, like that. Some security information in your home, some server line cameras are fitted. In any apartment at different places, server line cameras are fitted. By that server line cameras are generates the data. That data is stored in the security monitoring server. That in this case, in middleware B, top to bottom data integration point. Here data integration point, same application. From that application, suppose in medical server, in this case middleware B means the doctor extract the patient's information from the medical server and compare with the current information. That is the middleware B. Middleware B means at the doctor side. Suppose here we use application support protocols, network connectivity, local connectivity, and device hardware. At the medical side, physician side, we use laptops and mobile phones for getting the information. That is also called as tablets, mobile phones, laptops, all are devices. These devices are connected by using some local connectivity. Again, Wi-Fi connectivity is used generally. Without Wi-Fi connectivity, there is no internet access. Some network connectivity. Network connectivity means some IPv4 version, IPv6. Based on that applications, we use these protocols. Application support protocols. In generally medical applications, we use COAP by UDP or HT. Here, patient doctor is not, physician is not search the patient information through web pages. That is the reason HTTP by TCP is not used here. Only constrained application layer protocol and UDP protocol applications are used here. This is the protocol general view. This is the protocol general view. Next one, nodal capabilities. Nodal capabilities. First one is basic nodal capabilities. First one, retransmission. Suppose the data is sent from middleware A to middleware B. Suppose the data is sent from middleware A to middleware B, successfully reached to middleware B. The middleware B send positive acknowledgements. This is the data. Suppose sometimes the data is not reached. The middleware at B side, doctor side, is at the patient side. Here at the doctor side, doctor side asks retransmission. Retransmission. After middleware A taking that RTT round trip time. Again send same data to middle. Whatever the data lost during the transmission, the same data is sent to middleware B after a round trip time. Recovery is immediate. Recovery is immediate. Retransmission means network recovers from packet loss or inform application. This is one of the capability. Network recovers from packet loss. Next one, scale. What is a scale means selecting of sensors. Suppose in body area network, consider some sensors, 4-5 sensors. Some in some cases, wireless sensor network sensors nodes are randomly placed. In case of a forest, sensor nodes are randomly placed. Detect the fire condition in the forest, animals tracking, like that. Thousands of nodes are used. Some applications, few nodes are used. Some applications, thousands of nodes are used. In between, some provide some communication among these nodes. That is called as scaling. Next important capability is multicast. What is meant by multicast? Multicast means to transmit a single message to a group of recipients. Transmit a single message to a group of recipients. That means multicasting is sending an email message to a mailing list. Message sent from one person to group of persons. Same message is sent from one person to group of persons. TV transmission. TV9 station generates the same information and it's sent to group of peoples. That is called as multicasting. Duplicate suppression. Suppose duplicate data again and again generated. Duplicate data is generated. It consumes more bandwidth. It disrupts the operation of the devices which are in M2M devices area. That is the reason duplicate packets must be suppressed. Emergency messages. Sometimes the patient condition is very critical. Doctor suggestions are very, very important. That information is compulsory. That information is called as emergency information. Compulsory is sent from doctor to patient based on that patient conditions. Next one, polling of nodes. Polling of nodes. What is meant by, everybody must know the polling. M2M devices are there in devices area. This is the device 1, 2, 3. Device 1 having some data is ready to send to device 2. Send some request to second node and a request to third node. Second node is ready to receive data from first node. Send positive ACK. Therefore, first node send data to second node. That is called as polling. The third node is not willing to receive data from first node. The third node send NEAK, negative acknowledgement, to first node. This is the sequential, step-by-step sequential and independent of independent of responses. Independent of responses means the device 1 having data without any consultation of second node and third node. The device 1 send data to second node, third node, and fourth node, and so on. That is called as independent of response. Sequential means the device 1 having some data wants to send to second node. The device 1 send request to second node. Second node is ready to receive data from first node. The second node send ACK to first node. Therefore, the first node send the data to second node. Sequential. Next step is not here simultaneous operations are not possible. The device 1 send to request to the third node. After completion of the communication between 1 and 2, that is called as sequential operations. Model next. Model supports peer-to-peer, and device to device. Two individual devices are directly interact with each other. Every two devices are not a client or server. Two individual devices directly communicate with each other. Capabilities is the capabilities. Discovery of nodes. Discover node capabilities. Next, security. Security. Strong and encryption is very, very important. Mutual authentication, protection against record plain black attacks. Okay, convert this original data into another form. That is called as security. Provide some any third party person wants to access your data. We have to create a login ID passwords. That login ID password shared to the third party person. That person is willing person. Okay, share your password and login IDs. With the help of that login ID and password and share your data. That is called as a security. With this nodal basic nodal capabilities are completed.